All right. So today's discussion, right? It's actually a discussion. The paper, I mean, the question discussion will be mainly focused or will be focused on frequency distribution tables, right? The question I've sent, it has focus on those questions, right? So then that will be the target today, right? Remember, it's an easy, a small concept, right? A small thing to understand, an easy thing to understand, and an easy scoreable marks question, right? It's always the same pattern. You definitely have to find the mean value in every question. That will give you 4 marks, 4 to 5 marks, half of the marks. Okay. Then using that mean, we're going to answer some question. If you understand what is a mean, then forward on, you can answer the question related to the mean. Okay. All right. Mike. Wait, give me 2 minutes. I'll find a mic and come. Give me 2 minutes. Huh? Actually, that mic is from the institute. I couldn't find it, right? Is the voice that bad? Is my voice clear enough? Others, everyone? Is it clear? Can you hear me clearly, word by word? Yes? Okay, fine. Okay. Right. Yeah, the questions are on the channel, right? On the channel, you can check the channel. The questions are on the channel. Yeah. All right, fine. We'll start then, right? So then, like I was saying, whole essay question, right? If you take your part two, you have A part, B part. This question come up in your A part. Mostly the sixth question, but then don't worry, it might vary here and there, but usually it's in the A part. Okay. All right. Now, what is this frequency distribution table, right? Now, I'm not gonna give you the whole idea because if I do, I'll take 1 hour just for that. But I'll tell you this, right? Whatever that you need just to answer the questions. Okay. So they give you a table with some collected data, right? That is a set of numbers. For example, if you take you start collecting heights, right? Heights of students, height of anyone. Just give you an example, right? When you collect these heights, these are just set of numbers, right? So what they have done, they have arranged those numbers from ascending to descending, and they have putting them into certain groups, right? Now, each of these groups are of the same size. Okay, for example, let's say the first group, the size is 10. That means, let's say, starting from 100 centimeters, the height, right? 110 centimeters to 110. So you can see here the size of this group, right? Size is the largest number minus the smallest number here. That is the size. That is 10 centimeters. So likewise, every group here that they give you will have the same size. Okay, that is one thing that you have to know. So what they do, they collect data. Guys, mute your mics, okay? Unless you want to ask a doubt, yes, you're more than welcome, right? So like I said, what do we do? You have collected some data. We'll read the question and see what type of data are they, right? So then after the data is collected, they are not giving you all the data, right? So then when they are giving you, they're not giving you all the data. What they are doing, those data, those numbers they have collected, they are grouping them, right? In a way that all the groups are of the same size. That is, here the difference between the largest and the smallest is 10. Here the largest and the smallest is 10. Largest and the smallest is 10. So likewise, all the groups here will have the same size, right? Now, each of these group here is called a class interval. Class interval is another name for what? The group here, right? So each of these groups are called class interval, and the largest value, right? You have two values, right? Starting value and ending value in a group, right? So one group is called a class interval. The larger group is called what? The upper limit of the class interval. And the smaller group is called the lower limit. So each class interval has an upper limit and a lower limit. So if you take this class interval here, this is the upper limit and this is the lower limit. In part 1 question, they do sometimes ask you which class interval. Yes. Any doubt? Right? Giving a class interval, asking what is the upper limit of the class interval, what is the lower limit of the class interval, and they ask you what is the size of the class interval. One of the easiest questions you can answer. Okay, you didn't understand that? Please unmute now. You ask me what is the class interval and what is upper limit and lower limit and what is the size. Size of this group means, or size of the class interval means they're asking you the size of this group. Okay, right. So then in this question, they give you, right? They give you a column called class interval. Class interval is what I just explained you. Class interval is they collect a set of data. They don't give you all the data, right? From A to Z. Let's say they collect 300 heights. They don't give you all 300 heights. What do? They put them into certain groups, right? And they give you each group, how many of them belong to that group. For example, here, you're collecting heights of students, right? So then here, they'll tell you, okay, from 100 to 110, how many students are there? From 110 to 120, how many students? 120 to 130, how many students? Likewise, okay? These are called frequency. Frequency means the number of data. Here, the data is the students, so number of students, okay? So they'll give you a table with a class interval, that is the data put into certain groups, right? Then you don't have to know how these groups are formed, okay? So then they'll give you each group, what is the frequency or how many data belongs to that group. This is what given in your question, right? Now coming back again, a small bit of theory. When you collect a data, right, you can explain this. There are two types of data. One is called a discrete data. The other is called a continuous data. Just easily remember, discrete data is when the numbers have, when the data has only whole numbers. Right? For example, the number of members in your family. When you collect data, you go ask each person in the classroom how many members in your family. They definitely will give you a whole number. They won't tell you there are 1.5 members in my family. Impossible. Right? Okay. So then this type of data where there cannot be decimals, only whole numbers, you call those data discrete data, right? And here, the data which can contain whole numbers, there can be whole numbers, but most importantly, they contain decimals, right? They contain decimals. Now, this type of data, like for example here, height will not be a whole number, right? Most of the time, it is a decimal, 110.5 centimeters, 111.2 centimeters, something like that, right? So when the data contains decimals, you call them continuous. When the data contain whole numbers, you call them discrete data. Okay, whatever it is, when you collect data, right, you explain them using three tools or three characteristics, right? That is called the mode, the median, and the mean. What is this mode, median, and mean? Right? Mode is, let's say you collect 300 data, like an example I gave you, right? 300 heights of students. Okay. So then what do? In that 300, what data, for example, let's say 122.5 centimeters, that data has repeated highest number of times. For example, let's say out of these 300 students, 50 students is at a height of 122.5 centimeters. That is the highest repeated time. There can be other data that is repeated as well, but this data has repeated the highest number of times. In other words, we use the description for mode, most occurring data. That is the data that has been repeated many times, the highest number of times, that is called the mode. The thing here is, in this, when they give you the question, they never give you individual data. Like I said before, what do they give you? They give you groups of data, or in other words, class intervals. Okay. Now, when they give you class intervals, you can't find the mode. Why? Because individual data is not given. You can't tell, okay, this 122.5 centimeters, which is repeated 50 times, is the mode. You can't say that. Why? Because individual data not given to you. But yes. Yes. Yes, someone? Any doubt? You can hear me, right?
Yeah, Abdullah happening.
Sorry?
Class intervals, what is meant by size?
Size. Okay, good. Thank you. So then size of the class interval means, like for example, see here, this class interval is starting at 100 and finishing at 110. So then if I ask you what is the size, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, I'll tell you why we don't count 110. Now here I counted how much? 10. So the size of the class interval is equal to 10. What is the size then? The difference or the subtraction of the lower value from the higher value, that is 110 minus 100. Okay, so here the size of the class interval is 10. So I told you each class interval will have the same size. So if you see 120 minus 110, that is also 10. 130 minus 120, that is also 10. So likewise, each class interval will have the same size. Okay, so this is a group. I told you when they collect data, they won't give you individual data. They will group them and they will give you certain number of groups. This number of groups can change according to the question. But usually the standard number of groups is 10, but it's not a fixed number. Okay, they can give you any number that they want according to the question. Nevertheless, each group will have the same size. Or you don't use the word group, use the word class interval. So then each class interval will have the same size. There is an upper limit and a lower limit. So when you want the size of the class interval, what do? Upper limit minus the lower limit. Is that clear?
Yes, sir. Thank you.
Okay, you're welcome. Right. So where were we? So we are talking about mode, right? So when you get a set of data, the most occurring data is your mode. I gave an example, 122.5 centimeters repeating 50 times. Then that is your mode, 122.5. But here, according to the question, they're not giving you individual data. They're giving you class intervals. So then we modify this and we call this model class. So then probably you understand by the word model class. Here mode is an individual data, one data. But here we don't have one data, we have a group. So then the most occurring group, which group is repeated many times, or in other words, which group has the highest number of data, right? For example, let's say you have 10 here, 15, 25, 38, and let's say 23 here, right? So each of these group or class interval, I use the word class interval from now on, right? So each of these class interval, you can see here the frequency is given. The question is, what is the model class? What did I tell you the example? What is the meaning was? The model class is a class interval that is repeating the highest number of times. Or in other words, the class interval with the highest frequency, right? Now here tell me, what is the highest frequency among this?
38.
Definitely 38. Then if they ask you what is the model class, don't give it as 38. I'm seeing some of you students give it as 38. What is the meaning of model class? The class interval, not the frequency, the class interval which is repeating many times. So the highest number of frequency with the class interval. So you give the class interval, not the frequency. Okay. So 38, this class interval is repeating 38 times. So that means this class interval is your model class, right? So the question, if they ask you giving the table, what is the model class of this distribution? Your answer will be 130 to 140 centimeters. Don't forget the units. These are height. Height is given in centimeters. So 130 to 140 centimeters. Is that clear, everyone? What is the model class?
Then
Yes, sir.
is mode and model class is the same?
Mode, yes, mode and model class is the same. One tiny difference. Mode is for a single data, one single data. Model class is for a group. Is that clear? You understand the difference?
Yes, sir. Thank you.
Right, you're welcome. So then, when you get a set of data, we describe it using mode, median, right? What is median? We describe what is mode, what is median, right? Median, you arrange the data from ascending to descending, all the data that you have, and you take the data right in the middle, the 50th percentile. You call it the percentile. We'll not focus on the median today. It's another different unit, right? Along with maybe next week or the week after, right? We'll focus more on the median, right? But for now, just remember what is median. When you arrange the data from ascending to descending, the data right in the middle, right? All the data is 100%, right? So the 50th percentile is your median. We'll not focus today, next class or class after. Okay. Our main target today is your mean value, right? Your mean value. Okay. Right. Now I talked about discrete data and continuous data. A quick word about them also, right? So then when you look at your class interval here, you can see here the class interval, if you take the first class interval, the ending is at 110. Then here the beginning is at 110 as well. Now my question, if you get a data as 110, where do you put it? Is it for the first one or is it for the second one? Yes, you guys can answer.
Second one.
Second one. Any other answers?
The
Second.
first one.
First one. Right. It depends on the question. Right. You have to read the question carefully. Let's say this is a question I'm giving you. They will give you what a class interval means. Right. We'll look at the question and you'll understand. Right. So then I'll tell you the standard first of all. The standard way, right? Unless they give you in the question. Remember, right? Most of the time they give you what this class interval means if they didn't give you what to do. Okay. The standard way is, this is how you read the class interval. Okay. Any data, right, that is equal to 100, more than 100, and less than 110. Again, any data that is equal to 100, more than 100, and less than 110. Same thing applies to all the class interval here. Anything equal to 110, more than 110, and less than 120. Likewise, you can apply everything to all the class interval. That is a standard way. But most of the time, not every time, I won't tell every time, most of the time, they give you this in your exam paper. Okay. Sometimes it can be the other way around. They will tell you in the exam paper, the data that is more than 110 more than 100 equal to 110 and less than 110. More than 100, less than 110 and equal to 110, right? So in that way, right, if you take the standard way, what was the standard? More than 100, equal to 100 and less than 110. In that way, you can't put the 110 to this class interval. Why? Because this class interval will take only data that is less than 110. So in that case, 110 will go to the second class interval. But if the question says the class interval is equal to, the class interval is more than 100, equal to 110, and less than 110, in that case, you will put the 110 in the first class interval. So then there is no fixed rule, but there is a standard rule. Unless they give you the rule on the question, you're not going to change the standard rule. Is that clear, everyone?
Yes, sir.
Yes? Right, good. We made that clear because they do ask question on that. Okay. Now,
Sir, can you
my
explain
question, we'll see.
that again?
Yes. Sorry, Nihla?
Can you explain it once again?
Yeah, I'll explain you with this question. I'll ask you. Tell me, how many students? Now we are following the standard base. What is the standard? Yes, the data, let's say if you take this class interval, any data that is 100, that is equal to 100, more than 100 and less than 110. Follow that, okay? Equal, more than 100, less than 110. Okay, I'll ask you, this is how they'll ask you the question, right? Among these students collected data, how many students?
சரி மனத்தை போதும் சரியா போய் திரும்ப போங்க
Yes,
போங்க அப்ப.
Parmila, you have any doubt? Oh, fine. I think that's a mistake, right? So then, tell me, I'll ask you a question. How many students are less than 120 centimeters in the class?
15.
No.
25.
Carefully. Any other answers?
Yes.
Okay, I got 15 and 25. Any other?
10.
10. So what was my question? How many students are less than 120 centimeters? So you can clearly see, if you take this group, all of these group people are less than 120. Also, obviously, these group people are also should be less than 120 because they are between 100 and 110. So in that case, if they ask you, how many students are less than 120, what are the groups you will take? You will definitely take this group and this group. So these two groups, right?
25.
So then, how many? 15 plus 20, that is
25.
20 students who are less than 120 centimeters. Is that clear, everyone?
Yes, sir.
Yes. Okay. Right. They can ask you, give it as a percentage. Usually that's a question. Right. So then what do you do? How do you give it as a percentage? See here, you find the total number of students in the class. That'll be 10, 18, 21. Then 4, 5, 6. 6 plus 5, that is 111. So then how do you give it as a percentage? First find the fraction of the students. That is 25 over 111. These are the fraction of students who are in the class less than 120. Convert it to percentage, multiply by 100. Okay? Right. Now that is clear. So we understood what is a mode, what is a median. I'll come to the mean. Okay, that's the whole question here. We're gonna discuss how to find the mean value, right? But before that, you have to understand what does this class interval means. Okay, that is one thing. And also, if they ask you questions regarding the class interval, you should be able to explain that. Okay, all right. Now, what is this mean value? If they give you a set of data, what does this mean value means? Another word that you might understand, you guys will understand, a mean is the average value, right? In this question, they have given you the height, right? Height of all the students, 111 students in the class. So here, the mean value means the average value of one student. Among these 111, what is the average value of one student? So what will you do? You will add all the heights of these 111 students and divide by 111. Now, if you take a report card, right, what do you have? You have all the marks. They have something called the average. How do you find the average? You add all the marks that you have got, you divide by the number of subjects. Same thing here, right? What is an average value then? You add all the heights of 111 students and you divide by the number of students here, you will get the average. Now we don't use the word average here, we use the word mean value. Is that clear? Understood? What is the mean value?
The number of students means, is it 5?
No, number of students. Can it be height then? Number of students?
111.
111. That is the number of students, right? Height is given here, right? 100 centimeters to 110 centimeters. How many students? 10 students. 110 to 120 centimeters, 15 students. Likewise, the height is given here. This is the number of students. Is that clear?
Yes, sir.
Right, good. Okay, now the problem is, right now we said, how do you find the mean value? You have all the heights of all the students, you add all the heights, divide by the number of students, you will get the average, the mean value, the mean height of one student. Thing here is, you don't have individual data. That's a problem, right? Do you have, there are 10 students who are between 100 to 110. Do you know the height of these 10 students? Individual heights? No. We know that they are between 100 to 110, but we don't know, what we don't know? Each student, what is the height, each one of them. Is that clear? So we can't add all the height here and divide by 111 to get the mean value. That's a problem, right? So how do we solve that problem? Okay, there are two methods to solve this, right? To find the mean value, there are two methods. One is called the FX method. The other is called the deviation method. So another deviation, you call it the assume mean method, right?
Excuse me,
Assume
sir.
method. Yeah,
Is this a past paper question?
the one I wrote on the board.
Yeah.
No. It's just an example, right? Just to make you guys understand. Now I'm gonna start. Okay.
Yes,
No,
sir.
no. Finding the median, part TR, right? Finding the median, I didn't discuss. We'll do it another time, right? It's another part. I'll discuss maybe next class or the class after, right? I just will start, okay? Right, okay. Right, so what are these two methods? The FX method and your assumed mean method. Right, I'll discuss with the past paper. And we'll take a past paper question. We'll try to do the past paper question. And on the way, right, I'll explain you guys what is these two methods, right? But let me start telling you, you don't need both the methods. Stick to one method. Know both of them, right? I'm not going to focus on the FX method because usually in your question, in your exam paper, they 90% of the time, they tell you use the assume mean method or any other method to find the mean value, right? So they give you both the options. Okay, so you don't have to worry. But the thing is, some past paper, very few of them, they stick to the assume mean method. They'll tell you use the assume mean method to find the mean value. So in that case, we can see the most important method is the assume mean method rather than the FX method. And another problem there, the FX method involves a lot of calculation, whereas the assume mean method very easy on the calculation, right? Now, let's say I'll tell you why, I'll show you why FX method is not, why FX method has a lot of calculation. It actually will take a long time for you to find the mean value, whereas the assume mean method takes a bit of a time for you to understand compared to FX method. But once you get a hold of it, it's easier from there onwards, right? Okay. Now take out one of your past paper. Let's say we'll not start with 2018. Or we can start with that. We'll start with take 2018 paper. Right. We'll not focus on the question much. Right. I'll just teach you how to find the mean value. After we have found that, we'll try to focus on the question. Right. I'll just draw the table. Right. Quickly. Give me like a minute. Right. This is the table given to you on the question. Right now, what are we trying to find? We are trying to find Right, we'll read the first part of the question so that we can understand what we are doing here. Right, 5, 8, 10, 12, 9, and 6. So then here they have given you number of items and the number of days. Now we are trying to find, see here, in the first group, what they have given 20 to 30 items, they have sold for 5 days. Okay. Second group, 30 to 40 items, they have sold for how many days? 8 days. Now here, what will the mean value or the average value that will give you? The average value will be the number of items sold per day. We are trying to find. Now here they have given in the question, they have this data is obtained from 50 days, right? So we have obtained this data from 50 days. Now what are we trying to find? We are trying to find the mean value of the number of items sold per day. For one day, how many items did they sell? That is the mean value here. Is that clear, everyone? Do you understand what is the mean value here? Yes?
Yes, yes, sir.
Yes, sir.
Right. Now the problem here, like I said, the average value, what will you do? On each day, you will find how many items sold and you will divide by the number of days. That will give you the mean value or the average number of items sold per day. But like I said, they do not give you individual data. Then what we do, right? We don't know these 5 people. We know definitely they sold data. Oh, sorry, they sold items. These 5 days, they sold items between 20 to 30. But individually, we don't know how many items they sold, right? So we can't tell they sold 20 items these 5 days. We don't know. We don't know if in these 5 days, they sold 30 items. But for definitely we know the minimum number they can sell is 20. The maximum number they can sell is 30. But when we are finding the average value, we can't take the maximum or the minimum, right? So then what do you do for calculation purpose to tell, okay, these 5 people, we tell, okay, they sold the middle number of items. That is the mid number between 20 to 30, because you can't take 20, that will be the way too extreme. We can't take 30, again a way too extreme on the higher side. So minimum extreme, maximum extreme we can't take. So what you do for calculation purpose, we take the mid value. What that means here, what is the mid value here? That is 25. So then what do you understand by this? That means these 5 days, on each day, they sold how many items? 25 items. So these 5 days in total, just to give you an idea, these 5 days in total, how many items did they sell? One day they sold 25 items. So then 5 into 25, what is that? 125 items sold in these 5 days. Now you might ask me a question, sir, right? Okay. But you told mean value was adding all the number of items. Now in this question, right? And dividing by the number of days. Now here, we are taking all the 5 days as what? Each day we are taking it as 25. Won't there be a difference in the actual mean and the mean value that we are trying to find here? Yes, there will be. It can be lower or it can be higher. But remember, right, these are called statistic questions, right? I'm just giving you an idea. These mean value, the idea is not to get a very accurate value. The idea is to get a approximate value. Okay, just keep that in mind. If you get that doubt ever, I don't know whether you get that doubt, but if you do get that doubt, right, how can you be sure these 5 days exactly each day that we stole 25 items? Yes, we don't know, right? But we definitely know what they are between 20 to 30. To make the calculation easier or to make it a bit more accurate, approximately somewhat closer to the answer, what do? We don't take 20, we don't take 30 because those two are extreme. We take the middle value. So these 5 days, we have sold each day 25 items. Now, do you understand what is the meaning of mid value? Why mid value is important? Is that clear?
Yes, sir.
Everyone?
Yes, sir.
Right. So then what you do? So for calculation purpose, for each class interval, because we can't work with 2 numbers, we need 1 number to work with. right? So then for each class interval, we take the mid value to do the further calculation. Okay. Now here you don't have to always think what is the middle number. Make this easy, right? The class interval size is 10. You take the mid number, reduce 5, you will take the middle number, right? But the proper way to do it, what do? You add the lower value to the higher value. See here, lower value plus higher value, and you divide it by 2. 20 plus 30 is 50. 50 divided by 2 is 25. Next class interval, 30 plus 40 divided by 2. What is 30 plus 40? 70. 70 divided by 2, 35. Next class interval, 40 plus 50 divided by 2. What is 40 plus 50? 90. 90 divided by 2, 45. Now you start to see a pattern here. What is the pattern? See here, the difference between each mid value, 25 to 35. What is the difference? If you subtract, that is 10. 35 to 45. What is the difference? 10. If you find the next one also, that will be 55. What is the difference? 10. So then what you can understand here is we'll connect that to the size of the class interval. Can someone tell me what is the size of the class interval here?
10.
10. So what do you understand there? The difference between two mid value and the size of the class interval, remember, it's always equal. Okay. So here it's 10, 10, 10. Here also it will be 10, 10, 10, 10, 10. So then you have to remember, if you find one mid value, right? Find the first mid value, and the next thing you're going to find is the size of the class interval. After you find the size, what can you do? You can keep on adding it. The size is 10, 25 plus 10 is 35, 35 plus 10 is 45, 45 plus 10 is 55, 55 plus 10, 65, then 75. Likewise, easily you get your mid values. Is that clear, everyone? How to get the mid value? And is that clear that why do we get the mid value? Yes?
Why do we get the mid value?
You're asking why do, okay, fine. Why do we get the mid value? Why do we get the mid value? Because when they give you a group of class interval, is a group, one group, one group, one group. These 5 people, we don't know whether they bought items or they sold items. Here sold, right? These 5 days, they don't know whether they sold 20 or 30 items. And we are going to calculate the mean value. We need to know how many items they sold. So then we can't take 20, it's too low. We can't take 30, it's too high. So we take the middle value. We say between 20 to 30, the middle value is 25. So on these 5 days, they have sold 25 items. Is that clear?
Yes, sir. Yes, sir.
Right. That is a mid value. Right.
Yes,
Now,
sir.
this is where the two method comes. I'm not going to discuss regarding the FX method. I'm going to focus on the assume mean method. Right. Okay. Now what do you do?
Excuse me, sir.
Yeah.
Sir, what if the mid value, not mid value, the class interval increases, like if it goes 20 to 30, then 31 to 40, 41 to 50. Can it go like that?
What do you mean increase? Like, for example, let's say 21, you are saying 21 to 30,
21 to 30 or
31 to
31
40,
to 40.
like
There's
this?
a gap. Yeah.
Yeah, okay. I'll tell you, but then not much tested, but you have to understand the difference, okay? So here, why now there is a difference between this frequency distribution and this frequency distribution. Okay. Now I told you there are 2 types of data. One is continuous, the other is discrete. What did I tell you? Continuous data, they have whole decimals, and discrete data, they have whole numbers, right? Now looking at a table, you can tell whether the collected data is discrete data or a continuous data. Okay. Now here, for example, let's say if you get 30.5, can you put that data into this table? 30.5. Yes.
Yes.
Yes or no? 30.5. Here 30, here 31. There is a gap. So 30.5. No.
No.
So that means this table is made for discrete. Why? Because discrete, you will never get decimals. Because you never get decimals, you get only whole numbers. They follow this class interval. But continuous data, you get decimal values. So always, if you take a class interval, you end with one number and the next class interval, you start with the same number for continuous type of data. But if it is a discrete type of data, you can make the class intervals like this. Now, do you understand?
Yes, sir.
But you don't need
Yes,
so much
sir.
focus on this. That's enough. Okay. They won't usually they don't give you if there's a question, then I'll focus more on that. Okay. But as far as I remember, there is no past papers that they give you regarding this topic, do they?
The
Okay.
2024 paper was
Okay,
like that, right?
fine. On that class, on that question, I'll tell you the difference. Okay. Don't worry. Right. We'll focus on this now. Right. So then we have got the mid value. Now the focus, remember, the whole focus today is to now in this question is to find the mean value, the average value. Okay. Now what do you do? Tell me, according to this table, what is your model class?
70 to 80. No. 50 to 60.
Ah.
50 to 60.
Look at the frequency table. Highest frequency is 12. This model class or this class interval is your model class. Right. These are the methods you have to follow. Okay. The first thing that you do, there is something called the assumed mean and the actual mean. Okay. Now what you do? We take the mid value, right? The mid value of the model class, that is 55 here, right? We assume, we think that because the highest number of people is in this class interval, we think that, okay, the mean value will be something closer to this 55. So what do? You do something called the assume mean. You assume, you think that the average value will be 55. Is that clear? That is called the assume mean. Okay. Now what do? You introduce a
Okay,
column
sir.
for the deviation. Yes.
So can you explain why did you pick 55 again?
Okay, I'll come to that. Let me finish. Then you'll understand. Okay, let me finish. Okay. So then, again, see here, why did I pick 55? Because I said that you look at the model class. This is your model class. You take the mid value. Now we think, remember, now forget about this. We think that these 5 people have sold 25 items. On these 8 days, they have sold 35 items. On these 10 days, 45 items. These 12 days, 55. These 9 days, 65. And these 6 days, 75 items. Okay. So likewise, we have got one value so that we can calculate. Now what do? You look at the highest frequency, that is your model class. We tell that, okay, we think, we assume, the word assume means think, right? We think that all the people here averagely have sold 55 items per day, but it's only an assumption. Why do we assume that? Because we think that most of the people have sold 55 items, so everyone might fall in that category. Okay, that is the assumption that we make. Now, according to the assumption, we introduce a column called the deviation column. What is this deviation? Right, something like this. We say that, okay, let's say I am this 55 here. Whoever the numbers less than 55, we call them, they have deviated, gone away from it. Deviated means going away, right? They have gone away because it's less, it's negative deviation. Now, the people who are front of me, again, they have deviated, but because they are forward, they are more than me, you call them positive deviation. Okay. Now, remember, this deviation is for one data. Okay, keep that in mind. Now, here, this 55, now me, right? If you compare me, right, I'm 55. I have not deviated from 55. There's no deviation to 55 because I'm standing right here. So deviation is 0. Whoever is more than me, they will have a positive deviation. Whoever is less than me, they'll have negative deviation. So then 55, because this is the mean that we assume, no deviation, deviation is 0. Now, whoever is more than me, these people will have positive deviation and these people will have negative deviation because they are less than me. Both are deviated, but because they are more, it's positive. Because they are less, it's negative deviation. Sorry. Right. Now we have to give a number to that deviation. How much more have they gone away, right, from this 55? Now 55, if you compare 65 here, it has gone 10 away, right? That is more than 55. So it's positive 10. So deviation here is plus 10. Right? Now, if you take 75 here, again, always we compare with 55 because that is the assumed mean. If you compare 55 and 75, 75 is 20 more than 55. So the deviation is plus 20. Same like that, we give the deviation here also. Right? So 45 here, negative 10, less than 10 for 55. Okay? So then the deviation is minus 10. Here 35 here, it's 20 less. So then minus 20. 25 here is 30 less. So then minus 30. So then this is how much each data. Right now we think here, these 12 people, one person has got 55. And we assume that, right, everyone averagely have, sorry, not everyone, every day, averagely they have sold 55 items. Now what do? You see, comparing to other groups, how much this assume, sorry, comparing to the assumed mean, how much these other groups have deviated, right? So then we have put the deviation, right? So then if you take one person in this group for one day, it has deviated by negative 10. How many days are there? There are 10 days. Okay. All right. Now, this is the deviation for one day. Now we have to find the total deviation, right? So to find the total deviation, what do? Deviation for one day multiplied by the number of days. We have the number of days here, right? So then a frequency is F, deviation is D. So we introduce a column called the FD. Okay, right. So then here, number of days is, we start with 0 here. 12 into 0 is 0. Now we can multiply the positive and the negative. Remember, these are deviation for one day. We are multiplying the number of days to get the total deviation. How much they have gone, whether all the people, now we are going to get a total deviation, whether all the data, is it more than the assumed mean or is it less than the assumed mean? That's the idea we're going to take. Okay, right. At the end of the calculation, you'll understand it better. Be a bit patient, okay? Right. Now see here, one person in this group has deviated by 10 from 55. How many people are there? There are 9 people. So in total, the deviation 9 into 10 is 90. One person has deviated by 20. How many are there? There are 6. So 6 into 20, that is 120. Likewise, we find the total deviation in each group here. Okay. Then what do? Negative and positive. We add them. Here, if you add the positives here, 90 plus 120, that is 210. We add the negative. Remember, negative will become more negative. Okay, you add the negative. 160, 150 is 310, then 410, minus 410. Plus 210, 410. Then here, we get the total deviation minus 200. Okay, right, I'll ask you a question. 55, I'm here, right? Now, all the people, remember how many, sorry, all the days, okay, 10 days. Now we assumed the mean value was 55. But now we have calculated how much all of these days have got deviated. It has got deviated positively or negatively, minus 200. So negatively, so the actual value, right? I thought it's 55. But it's actually deviated way behind me by minus 200. Now, tell me, will the actual mean value, I'm 55 here, the actual mean value is way behind. Tell me, will it be positive? Will it be more than 55 or will it be less than 55?
Less than 55.
Yes. Less than 55. The deviation is negative, right? I started with that. I thought 55 is the mean value, right? But then we compared each of them with each categories. Then this is for one person. Depending on the number of people, the deviation, we add it up. The final deviation is minus 200, which means it is way behind what? 55, right? So it is less than 55. Now the actual value will be less than 55. Now we have to calculate how much less than 55. Okay. Now see here. This FT, we have added all of them. Addition in mathematics is called sigma. So we have got the value of sigma FD. This is your addition of all the deviation. That is sigma FD, right? Now this is the deviation for everyone. We need to find. Now we think one day it's 55. Now we have to find the deviation for one day, right? The deviation for one day. This is for deviation for all the days here, right? Now we have to find the deviation for one day. How do you do it? Deviation for all the days divide by the number of days. So sigma FD divide by sigma F. Okay? Sigma FD is the total deviation for all the days. We have 50 days. Sigma means addition. We are adding all the number of days, that is sigma F. This will give us the deviation for one day. We think the mean value is 55. So then, if we have the assumed mean, see here, assumed mean value. See here, the assumed mean value, we think it's 55, but we know the deviation is negative, which means what will happen? Let's say here, we'll find the deviation first of all, right? So then I'll tell you how this equation is formed. You have the assumed mean and we find the deviation and we see if the deviation for one day is positive, the actual mean value will be more than 55. If the deviation for one day is negative, the actual mean value will be less than 55. Now, first of all, we find the mean value. See here, the total deviation is minus 200. There are 50 people, 50 days. So we divide by 50. So then you will get minus 4. That means we thought it was 55, the mean value, but is actually 4 less than 55, which is negative. So then what do you do? What does that mean? 4 less than 55 is 51. So then that is how the equation came. 55 minus 51, minus 4 will give you 51. So this is the equation, okay? The mean value, mean is equal to assumed mean plus, this is the deviation for one day according to this question, okay? So deviation per data, this is the deviation. So assumed mean plus deviation per data will give you the actual mean, okay? So then 55 minus 4, that is equal to 51. What is this 51? 51 items per day, right? So for one day, they have sold at a mean value, at an average value of 51 items per day. Is that clear, everyone?
Yes,
Yes,
sir.
sir.
Yes? Quick
Yes, sir.
recap. You will get the class interval and the frequency. What you have to do? Arrange 3 more tables. One is called the mid value. I explained you clearly why you need the mid value, because we can't deal with 2 numbers. We need 1 number. So we open a column called mid value. Then what do? You take the mid value of the model class as the assumed mean. That is the mean that we think. Why do we take that? Because we think most of the people, they have got in this class interval. So the mean value will be somewhere around there. So we take the 55. Then what do? You see how much each of them has deviated. Is it more than 55 or less than 55? Introduce another column for the deviation. Then this is for one day or for one data. Depending on the number of data, we calculate the total deviation here. Now we have got the deviation. Now we have to find the deviation for one data. So we divide by the total number of data. We get the deviation for one data. We add it to what? To the assumed mean, the mean that we thought it will be. If the deviation is positive, the final mean value will be more than the assumed mean. If the deviation is negative, then the actual mean will be less than the assumed mean value. Is that clear, everyone? Okay.
Yes, sir.
All right, good. Now get by the question, we'll see what they're asking for. I will complete the question. 2018, sorry. Right. So then Nimal is involved in a small industry which produces sport items. Information regarding the number of items he produced each day during period of 50 days is shown in the following frequency distribution. Nimal gains a profit of 60 rupees by selling one of the items, right? So one item, he's getting a profit of 50 rupees. He expects to gain a profit of 370,000 rupees during the next 120 days. So then, remember we found out he's selling 51 items per day. So we can find out how many items he's selling for 120 days, right? And we also know what is the profit of one item. Then we can find the total profit. That's what they're asking for, right? Now, question, find the mean number of sport items he produces per day. That's what we have found here, and show with reasons whether his expectation is fulfilled. We'll see, right? So then, first of all, we have to find the number of items he's selling for 120 days. So for one day, he's selling 51 items. For 120 days, 51 into 120. Okay. So then if you do the multiplication, 51 will add the 0 later. 51 into 12. 1 into 2 is 2. 2 into 5 is 10. 0 here. 1 into 1 is 1. 1 into 5 is 5. 2, 1, 6. You add the 0. That is 6,120. So then in this 120 days, he's selling 6,120 items. One item is how many? What is the profit? 60 rupees. So then what do? You multiply this by 60. Again, we'll forget about the 0. We'll add it later. 612 multiplied by 60. We'll add that 0 also later. So 2 zeros, huh? 6,120 multiplied by 60. We had to add 2 zeros later. 2 into 6 is 12. 1 into 6 is 6 plus 1 7. 6 into 6 is 36. Then add the 2 zeros. Right. So then how much is he receiving? 67,200. So then you can tell, is he achieving his expectation?
No.
No. So then you can tell 67,200 is less than, sorry. 367,200 is less than 370,000. Therefore, his expectation is not fulfilled. Right, so according to this question, definitely for whole of this calculation to find the mean value, minimum you will get 6 to 7 marks. This will give you only 3 marks. Okay, you can see how easy you can gain these marks. Okay, everyone.
Yes, sir.
Yes.
So in the question they have asked find the mean number, no?
Yeah.
So is it assumed mean or mean?
Mean. Now we assume a mean value. Using that, we found the mean value. Mean is equal to assume mean plus sigma FD over sigma F. We calculated and we found the mean value. Okay.
Yes, sir.
So if we calculate the mean number as well as the assumed mean number, is it the same answer?
No. Assume mean here. Now, okay, I'll come to that here. Now, to do the calculation, remember, we can take any of the mid value as assumed mean. I told you we take 55, right? But if you do the calculation by taking any of these mid value as assumed mean, finally you will get the same answer. Understood? Assumed mean is just a pathway for you to find the actual mean. Another student can take 45 as the assumed mean and get final answer the same thing. Another student can take 75 as the assumed mean and still get the same mean value. Is it understood?
So in the question they have asked mean, no, not assumed mean. No, that's
Yeah,
what
we
I'm
found the mean values here. Mean is equal to assumed mean plus sigma ft over sigma f. Now remember, assumed mean is very subjective. Each person can take different assumed means. It's just a pathway for you to find the actual mean value. Okay.
Okay, sir, understood. Thank you.
Excuse me, sir.
You're welcome. Yes.
Excuse. You had used the assuming like deviation FD method, right?
Yeah.
I use the fx method. I still got the answer, the same
Yeah,
answer,
yeah.
but the steps are different.
Yeah. You get the same answer. FX method, you get the same answer. The problem with FX method, see here, what do you have to do? You multiply the frequency with what? With the mid value here. It's a large calculation. What we did here is a very small calculation. F into D. Deviation is always a whole number. It's most of the time multiples of something. So it's very easy to calculate. Is it understood? That's why we focus on the deviation method rather than the FX method. FX method, then just imagine if your mid values were decimals. If it was decimals, you will take a large time to do the FX method. That's why we stick with the deviation method. Is that clear?
Yes, yes, clear.
Okay, welcome. Now keep in mind, right? Now you might think I just explained very fast. Yes, because we have a very constrained, restricted time in class. We explain the whole thing, right? There are class students of mine, right? So then we explain from A to Z on how this is working, but I can't do the same thing because very limited time. Okay. So with the time there, I hope I have given you the best idea for you to focus on the questions. Okay, right. Now we'll go to the next question. 2000. Come 2022. The third question I've sent you, right? I'll come to the others in a while. Come 2022. I will start doing the
So which year?
2022. Now remember, you can use the FX method, right? Now today in class, I'll be already discussing deviation because I feel like that is the best method to use rather than FX method, right? Especially in the exam where you make a lot of mistakes on small calculations, right? So in that case, deviation method is easier. If you, especially when you practice, it becomes more easier than the FX method. Okay, so try to be a bit more thorough on the deviation, especially if they tell you to use only the deviation method, then that becomes a problem. That means not deviation, it's called the assumed mean method, okay? Right. All right, now what they have given here, distance. Here it is given as distance in kilometers. Now these units are very important. When you give your final answer, there should be units, right? Don't just give numbers. Units should be there. Okay, that's why they give you the units. Here, number of trips. That is your frequency. Any mid-value deviation won't change. Okay. Now we'll see here 1 to 3, 3 to 5, 5 to 7, 7 to 9, 9 to 11, 11 to 13, and then 13 to 14. Right, can someone quickly tell me what type of data is the distance or kilometers? Distance is what type of data? Is it discrete or continuous?
Continuous.
Continuous. Okay, because continuous data only deal with decimals. Your distance is always, most of the time, not, I won't say always, but most of the time they are decimals. So then it is a continuous type of data. And also looking at the class interval, you can tell it's continuous. Why? Each class interval is ending and the next class interval is starting with the same number, same number, same number, same number. So then those type of class intervals or frequency distributions, you can easily tell they are continuous type of data. Okay, right, read the question first of all. A frequency distribution giving the number of trips that Nimal made in his car during 2 weeks together with the distance is shown in the figure. Okay, so the distance and the number of trips that he has made. Now, can someone quickly tell me using this idea, what will be the mean value? What do you understand by the mean value? Yes? Anyone?
The distance he traveled?
Distance traveled so in how many trips?
One.
In the number
One
of
trip.
trips.
Okay, the distance traveled in one trip. That is the mean. That is very important to understand. Most of you guys don't understand, right? So looking at the table, you should understand what the mean value will give you. That is the distance traveled averagely or mean value. That is distance traveled per trip. Okay, that will be the mean value. Okay. Now, the number of trips, first thing that you do is calculate the number of trips. 6, 10, 16 plus 20, that is 36, 40, 50. So there are 50 trips he has made, the total number of trips. Right. So then question here. Now see there in the bracket, I told you they'll explain you the meaning of the class interval. Below the table, here the interval 3 to 5 represents greater than or equal to 3. Whatever the data, greater than or equal to 3 and less than 5. So they are following the standard way. Okay. Roman number 1. Find the mean distance he traveled on a trip during these 2 weeks. They are telling you to find the mean value. Quickly, what do you do? Find the mid value. First thing what you do, find the mid value of the first class interval. 1 plus 3 is 4. 4 divided by 2 is 2. Now you are not going to add and divide every time. I told you a trick. What do you do? Find the size of the class interval. Can someone tell me what is the size of the class interval here?
2.
2. Right? Size is 2. Then what do you do? How do you find the next mid value?
2 plus 2.
You add 2 here. 2 plus 2 is 4. How do you find the next one?
4 plus 2.
You add another 2. 4 plus 2 is 6. So you keep on adding 2 to get the next mid values. Okay? Right. Now what do you do? After you have got the mid value, you assume a mean. The best thing I told you, can assume any mean value, right? Each person can take different mean values, as different assumed mean values. The final actual mean will be the same for everyone. Okay, but I told you, or unless sometimes this question they tell you specify what mid value to take as assumed mean. Unless they tell that, you always go for the mid value of the model class. Okay, now your model class is this 20. This is your model class. Frequency, highest number of frequencies is your model class. Take this as your assumed mean. Right? Once we have got the assumed mean, you know the assumed mean has no deviation. 6 won't get deviated from 6. There's no deviation, 0. Right? But 8 is getting deviated from 6. It's more than 6. So it's definitely getting deviated. Right? By how many? You have to give a number positively by 2. Right? 10 getting deviated, it's more than 6
4.
positively by 4. 12 more than 6 by 6. 14 more than 6, but give a number. How much more? 8 more, right? So then that is your deviation column, right? Likewise, at the negative deviation as well. So then 4 less than, how many less than 6? 2 less than 6, so minus 2. 2, how many less than 6? 4 less
Minus
than, so minus 4. Likewise, you complete the deviation column. Now, this deviation is for one trip here. Now, here number of trips, right? So there are 6 trips. So then you have to find the total deviation for all 6 trips. How do you find? Number of trips divided by the deviation for one trip. 6 into minus 4, that is minus 24. Okay. So likewise, you find the deviation for each row, total deviation. 2 into minus, for 10 into minus 2, minus 20. 2 and 20 into 0 is 0. 8 into 2, that is 16. 4 into 4, again 16. 0 into 6, 0. 2 into 8, that is 16. So if you did the FX method, you will do a much more larger calculation. Then you can see how simple the calculation is, right? Then what do? You add the positive and the negative separately. If you add the negative separately here, you have minus 44. If you add the positive separately, 16, 16, 16 is 48. So then if you do the addition, 48 minus 4, that is 4. The total deviation now. The total deviation is 4. Your assumed mean is here. The actual mean is deviated positively, which means, tell me, is the actual mean more than 6 or will it be less than 6?
More than
More
6.
than 6.
More than 6. You should have an idea. Then only your final answer, you can think whether it's correct or wrong. Okay. So then you apply the equation. Assume mean is mean value is equal to what? Assume mean plus sigma FD means the total deviation divide by sigma F. That is the number of frequency here. So total deviation divided by number of frequency will give you deviation for one data, right? You add that with the assumed mean, you will get the actual mean value. Okay. So then the assumed mean we got was 6 plus then 4 sigma FT divided by 50. Okay, we get a decimal value here. We'll see what is the decimal value. We can divide by, we can do the division here. 4 divided by 50. 0, we can't, 15 to 0 is 0, that is 4. Then what you do? Place a decimal point, bring a 0 down, 40. Place decimal point here as well. Again, you can't do the division, another 0, right? I'm not going to put the 0, I don't have space. Then you take another 0 down, that is 400. 50 into 8 is 400. So then what you have here? 6 plus 0.08. So then 6.08 kilometers, remember, per trip, right? Just put kilometers, but in your mind, it should be kilometers for one trip. Is that clear, everyone, how to find the mean value?
Yes,
Yes,
sir.
sir.
Right, good. Okay, that is Roman number 1. Roman number 2. For a certain reason, Nimal expects to make 120 trips, such trips during the next month. For that month, he is entitled to exactly 80 liters of fuel, right? To be able to make the 120 trips in his car, on average, what is the distance his car should be able to run on a liter of petrol. Okay. So now they are asking the efficiency of the vehicle. That means now this Nimal, he's taking 6.08 kilometers for one trip. Now he wants to do 120 trips next month. Question is, he has only 80 liters of fuel. Now his car, how much kilometers it should run for 1 liter of petrol? That's what they're asking, right? How much it should run for 1 liter of petrol. So how much kilometers? So we need the total kilometers in order to find how much kilometers it should run for one petrol. That means if you
Can
have
you
the
explain
total
the
number of
question?
kilometers, divide by the number of liters here, then you will get what? You will get kilometers per liter, right? So for that, we need the total number of kilometers. We know the kilometer for one trip. We know he's making 120 trips. Then someone tell me, how do we find the total number of kilometers?
6.08 into 120.
Easy, right? One trip is 6.08. He's making 120 trips. Then what do you do? 6.08, Roman number 2, right? 6.08 into 120. This will give you the total kilometers that he's going to need for the next month, right? We'll do the multiplication first of all here. 120 is made up of 12 into 10. So 10 into 6.08, that will be 60.8 into 12. Right now we'll do the multiplication. Forget about the decimal point. 608 into 12, right? 8 into 2 is 16. 0 into 2 is 0. Plus 1, right? Plus 1, that is 1. 2 into 6, that is 12. Leave a space here. 1 into 8 is 8. 1 into 0 is 0. 1 into 6 is 6. 6, 9, 2, 7. Don't forget about the decimal point, right? So then one decimal point here, one decimal place. So then he's going to travel 729.6 kilometers. So then they are asking, how much should the car travel, the efficiency of the car? How many kilometers for 1 liter? So then what do? 729.6 kilometers. He has only 80 liters of petrol. Divide by 80, right? Now we'll do the division here quickly. Again, forget about the decimal point. We'll add the decimal point later. 7296 divided by 80, right? So then what can we do? Yes, we'll take 720. 80 into how much is 720? Yes, 80 into 9. 80 into 9 is 720. Remainder is 9. Bring the 6 down, 96. Then 80 into 1. Something. Yeah, okay. 18 into 1. So then that is 80. Remainder is what? Remainder is 16. Now place a decimal point. Bring the 0 down, 160. Place a decimal point here as well. Then 80 into 2, that will be 160. So your answer, remember, we forgot about decimal point. So we have to move the decimal point once here. So then here, the answer should be 9.12 kilometers per liter. Did they tell you to round it off in any of the question? No, right?
Sure.
Did they tell you?
No.
No, right?
No, sir.
No.
Okay, you guys got this answer until now?
So I didn't understand the second question.
Second question. Now, second question, they are telling you, now this person is traveling for one trip, he's traveling 6.08 kilometers. Next month, he's going to travel 120 trips. For one trip, 6.08, he's going to travel 120 trips. Now, he has only 80 liters of petrol. The question they're asking, now each car, right, it will, depending on the car model, it will travel, the number of kilometers it traveled for 1 liter is different. Okay. So they are asking his car, how many kilometers it should travel for 1 liter? That's the question, right? So then how many kilometers it should travel for 1 liter? That means we should know the total number of kilometers, the total number of liters of petrol. So total number of kilometers divided by total number of liters, you will get the number of kilometers for 1 liter, like this here. Right? Number of total kilometers divided by the total number of petrol, you will get the number of kilometers for 1 liter. So for that, we need the total number of kilometers. So we know for one trip 6.08, multiply that by the number of trips, you will get the total kilometers, divide by 80, that will be the answer. That is number of kilometers per liter. Is that clear?
Yes, sir.
Right. Last one. Nimal decides to cycle instead of using his car for trips that are less than 5 kilometers. By considering that all his trips are as in the above table and that the car can travel 9 kilometers per liter on average. We got the answer 9.12, but now we have to use the word, now we have to use the kilometers per liter as 9. If a liter of petrol is 400 rupees, show that Nimal can save at least 1,600. Now, according to the above table, he is traveling any trips less than 5 kilometers in the cycle. Can someone tell me how many trips will he travel in the cycle?
16.
Very good. 16 trips. Here, less than 5. I asked you a question before also, right? So these trips 3 to 5, 1 to 3, all of them are less than 5. So 16 trips he will travel in the bicycle. So now we'll see how much is he going to save using those 15 trips. Okay.
I couldn't get the 16 part.
Which 16? The 16 part. So now
Yes,
they're
sir.
saying he's traveling whatever the trips less than 5 kilometers, he's traveling in the bicycle. See here, this is 1 to 3 kilometers. How many trips? 6 trips. 3 to 5 kilometers, 10 trips. 5 to 7 kilometers, 20 trips. So likewise, they have given you whatever less than 5 kilometers. So what are less than 5 kilometers? 3 to 5 is less than 5. 1 to 3 is less than 3. So these trips are the trips which are less than 5 kilometers. Now do you understand?
Yes, sir. Thank you.
Okay, so 16 trips. So then we'll see in these 16 trips, how many kilometers is he going to travel? We know for 1 kilometer, right? So for one trip, he's going to travel how much? 6.08 kilometers. Okay, for one trip, he's going to travel 6.08 kilometers. Now we have 16 trips. So then the total distance he's traveling in these 16 trips here, 16 into 6.08. That'll give you the number of kilometers, the average kilometers traveled in these 16 trips. Okay, so then do the multiplication. 608 multiplied by 16, right? So 6 into 8, 48. 4 here, 0, 4. 6 into 6, 36. Leave a space. 1 into 8 is 8. 1 into 0 is 0. 1 into 6 is 6. Addition, 8, 12, 1, 7. Right? So then 9. How many decimal places? 2 decimal places. Place a decimal point. So that is 97.28 kilometers. So then he's traveling 97.28 kilometers before he used the car. Now he is using the bicycle. We are going to see how much he is going to save. Now 97.28 kilometers, we have to find how much petrol he is saving because 1 liter of petrol is 400. So then, see here.
Excuse me,
Yes.
sir. They are saying at least 1,600. So should we see the minimum?
Yeah. Okay.
Should we see the minimum like 1 into 6 and 3?
No. Show that he can save at least. No. You have to do it like this, okay? You can't take the least value. They didn't tell least value, right? If they tell if he travel the least value of kilometers in that group, then you can take the least value. Understood?
Okay, sir.
Right. So then here 97.28 kilometers he's saving. We have to see how much petrol he is saving. So that is 97.28 divided by 9. Okay. So then if you do the division here, did I go wrong? No, right? Wait. Nimal decides to cycle instead of using his car for a trip less than 5 kilometers. By considering all restrictions above mentioned, if right. So that Nima can save at least, yeah, thank you for that. Right, good. So at least, good, right? So then here you have to understand the word at least there. So they are saying, show that he can save a minimum of 1,600, right? So then that means, right, you can see, and I explained this before. If you take the class interval here, these 6 people, they can travel, we can take that, a minimum of 1 kilometer, a maximum of 3 kilometers. But in this calculation, we took it as 2 average value. Here, these 10 people can travel a minimum of 3 kilometers, a maximum of 5 kilometers. But averagely, here to find the mean value, we took it as 4 kilometers. But here the question says, show that he can save at least 1,600. That means he can save, if he travel the minimum value, the least value, what is the least amount he can save? That's a question. Thank you, Ashura, right? So then here, that means we have to take these 6 people have traveled the least number of kilometers, that is 1 kilometer. And these 10 people have traveled the least number of kilometers, that is 3 kilometers. Okay. So then we can find 6 into 1, that is 6 kilometers, 10 into 3, that is 30 kilometers. So then in total, these 16 trips, he can travel a minimum of 36 kilometers. So 36 kilometers he can travel in how many liters? That's what we have to find. So 36 kilometers divided by 9, that is 4 liters. Okay. So he can save a minimum of 4 liters of petrol. 1 liter is 400, 4 into 400, that is 1,600. So that means if he travel the least number of distance, he can save how much? 1,600. Is that clear?
Can you explain the third part again?
Right. So the question says, see the question there. Nimal decides to cycle instead of using his car for all the trips less than 5 kilometers. So we figured out that were the 16 trips. Okay. By considering that all his trips are as in the above table and that the car can travel 9 kilometers per liter on average, if a liter of fuel is 400, show that Nimal can save at least 1,600. Now here, instead of that question, they give you, show that Nimal can save a maximum of 1,600. So in that case, we have to show, okay, these 6 people, what is the maximum they can travel? Each person can, so each trip, he can travel a maximum of 3 kilometers. Now they are saying least, which means minimum. So then each 6 trips here, he can travel a minimum of 1 kilometer. So here you have used the word at least, which is minimum. So it's 1 into 6. In these 6 trips, he can travel a minimum of 6 kilometers. In these 10 trips, 1 trip is 3 kilometers. So 10 trips, 3 into 10, that is 30. So in these 16 trips, he can travel a minimum of 36 kilometers. So he's traveling 36 kilometers. 1 liter, he can travel 9 kilometers. So 36 kilometers, he will need 4 liters. So he's saving these 4 liters. 1 liter is 400. 4 into 400 is 1,600. Is that clear?
Yes, sir.
All right.
Thank you.
You're welcome. Now come to question 2023. Okay. The following group frequency distribution that has been prepared using the information of the mass. Again, mass, tell me kilograms. Is it continuous data or discrete data?
Continuous.
Very good, continuous, right? So using the table, you can see there the ending of one class interval, that is the upper limit, and the lower limit of the next class interval is the same, right? So those are continuous type of data. Okay, right. So always write the equation when you're answering, okay? So then we'll fill the table here. So they have given you class interval that is in kilograms. This is in kilograms, mass. Okay. This is the number of students, right? Yeah, number of students. Other columns won't change. So then here 40 to 44, then 44 to 48, 48 to 52, then 52 to 56, then 56 to 60, 60 to 64, 64 to 60. 3, 5, 9, 11, 7, 3, and 2. So they have told you the class interval 40 to 44. What does it denote? Greater than or equal to 40 and less than 44. Okay. So then first one, to which class interval does the most number of students belong? Indirectly what they're asking you in this question. Yes. They're
Model
asking the mean,
class.
model class. Indirectly they're asking you for the model class. So what is the model class?
50 to 56.
Very good. 52 to 56. The class interval with the highest frequency, that is your model class, 52 to 56. Right, good. Then, problem number 2. Find the mean mass of a student in this group to the nearest kilogram. Okay? Right. So to find the mean value, it's the same. You can see, I'm not even erasing the table. It's the same thing we follow again and again. The values are changing, that's all. Right? So first thing we find the mid value. 40 plus 44 is 84 divided by 2, 42. We are not going to keep on dividing. Find the size of the class interval, that is 4. You keep on adding 4. So 46. Then 40, 50, 54,
58,
8, 62, 66.
66.
We have got the mean value. Then what do? You assume a mean. You can assume any mean, but I told you always assume the mean mid value of the model class. The deviation is 0 there. Whatever more is positive, whatever less is negative. So this is 4 more, this is 8 more, and this is 12 more. Here 4 less, 8 less, 12 less. Then what do? This is deviation for one student. We have to find the total deviation. Then you keep multiplying the number of frequency. 3 into minus 12 minus 40 minus 36. Then 4 into minus 8 minus 40. 9 into minus 4 minus 36. 11 into 0 is 0. 7 into 4 is 28. 3 into 8 is 24. Then 2 into 12, that is 24 again. Add the positives separately, negatives separately. Negatives, here we get 80. Sorry, not 80, 76. 76 plus 36, how much is that? 112 minus 112. What is the positive we have here? 28 plus 24 is, that is 52. 52 plus 24, that is 76. So then 112 minus 76, how much is that?
Minus 36.
26 or 36?
36.
36.
Right, so minus 36. Right. So this is your total deviation. How many students did they tell you? They didn't give you. You have to find the number of students. So find the number of students here. 3 plus 5, 8. 8 plus 9, 17. 28. 36. 36 plus 5.
40.
40.
40 or 41?
40, sir.
40.
So then we have got the number of students. Now what can we do? Assume mean plus sigma FD over sigma F. Now what does this give you? This gives you the deviation for one student. Okay. So then assume mean here. What is the assume mean? 54. 54 plus sigma FD, that is here minus 36. Divide by sigma F, that is 40 here. Right. So then we can do the division easily. 36 divided by 4. Can someone tell me now? Here 40 I can write as 4 into 10. 36 divided by 4, that is 9. 9 divided by 10 is 0.9. 54 minus 0.9, that is what? 53.1 kilograms. Right. So the mean value of one, or mean mass of one student, that is 53.1 kilograms. Is that clear, everyone?
Yes, sir.
Yes. Everyone okay?
Sir, to the nearest kilogram.
This is the nearest kilogram, right? Round it off the nearest kilogram. How do you round it off? Yes,
Yes.
if you round up nearest kilogram, where do you look at? you look at the first decimal place. If the
First
first decimal
decimal.
place is 5 or more than 5, then you increase the whole number. If it is less than 5, you keep the whole number as it is. So tell me what will be the answer?
53 kilograms.
53 kilograms. So then the round off value, that is 53 kilograms. Right. Okay. Problem number 2 that we've done. Problem number 3. The maximum total mass of the students who can be taken in a van which was found for this group of students who plan to go on a trip is 600 kilograms. So the van can carry only 600 kilograms. One student, the kilogram is 53. Keep that in mind. By using the mean value, that is 53 kilograms, find the maximum number of students that can be expected to travel in the van. So the maximum number of kilogram is 600. One student is 53. How do you find it? Anyone?
600 divided by 53.
Easy as that, right? 600 divided by 53. We'll do the division. 53 into 1, that is 53. Remainder is 7. Bring the 0 down. Again, 53 into 1, that is 53. Then what do you do? Remainder is 17. Decimal point, bring the 0. Let's say what you want decimal point. Place decimal point here, 53 into 3. Right. So then you can take approximately 11.3 children. Right. Now, you know, children can't be or students can't be decimal values. Do we take 11 students or 12 students?
12.
11.
11 students.
11.
Ah, remember 11.3 is the maximum value that you can take. Right? So you can't go to 12. So it should be 11. Right? So the maximum is 11.3. Then definitely if you take more than 11.3, the van will break down. So you have to take less than 11.3. That is, so your answer, right? You have to show that is 11.3. Then what you have to say? Maximum number of students is 11. So keep that in mind. Okay. Right. You most of the time you get these type of questions, right? So in that moment, you have to know whether what to choose, 11 or 12. Okay. Problem number 4. Find the maximum number of students that it may be possible to take in the above mentioned van based on the given frequency table, giving reasons for your answer. Okay. So the question is, find the maximum number of students that it may be possible to take in the above mentioned van based on the given frequency table, giving reasons for your answer. Right. Now tell me, the van can carry up to 600 kilograms. Okay. Right. Now, to carry the maximum number of students, right, we assume that one student is, if we assume one student is 53 kilogram, we got 11 students. But we know all of these are not 53 kilograms. Okay. Now tell me, if I ask you, using this table, find the maximum number of students that can travel in a van, would you take the heaviest students or would you take the lightest students?
Heaviest.
If you take the heaviest
Lightest.
students,
Lighter.
you put more. You take the lightest,
Lightest.
definitely, right? So you take the lightest students to put more number inside the van. Okay. But remember, it can take a maximum of only 600 kilogram. And next question. Right. Now, do we assume that these students, now for example, in this group, to take a maximum number again, do we take 44 or 40? Should they be, do we take
40,
lighter?
sir.
Do you take 40 or 40?
40.
40.
40. Why? To
40.
put more number, we
Yes.
assume, okay, they should be the least amount of weight. Is that clear? So we think that all these 3 students, if they are 40, we can put more inside the van, right? To get the maximum number, go for the lowest weight. Okay. Now, if you take these group here, we assume these 3 people are 40 kilograms. So then in the first group, these 3 children, they are 40 kilograms. So that is 120. Okay. First group, all the 3, if they are 40, the total kilogram will be 120. Next group, we think that all these 5 people, if they are 44, then that will be the least number of kilograms. So then 44 into 5, that is 220. We can take more up to 600, right? We'll go to the next 9. We assume these 9 people are 48 kilograms. So 48 into 9. You do the calculation. Did anyone do? Do the calculation. 72. 4 into 9, 36. 36 plus 7, that is 43. Right? So then 432 kilograms. We'll add this. 2, 5, 6. 762 kilograms. Bit of a problem. Right?
772.
72, sir.
Sorry. So then what do we do here now? I thought we get a proper answer, which based on the given frequency table. So then here you get 340. Right? Okay, see here. So then who is that? Who is sharing the board? Cut it, okay? Right, don't share the board. Okay. Now see here, we are on the track. Okay. 120 plus 220. How much is that? That is 340 kilograms. Now, out of 600, how much is remaining? 600 minus 340. Among these 9 students, we have to decide how many students we can put inside the van. Right? So 600 minus 340, that is 240. So then, whatever the number of students here multiplied should give you 240. 48 into what will give you 240?
260.
Into 5, right? 48 into 5 will give you 240. So out of these 9 students, if you take 5 students, 48 into 5 will give you 200. Sorry, it should be 260, right?
Yes,
Right.
sir.
Yeah, sorry. 260, right? So anyways, we can't take 6 here. If you take 6, give me a moment. I'll write it down. Right. Sorry about that. So, right, if you take 6 here, definitely it will be more than 260. So 5 is the correct answer here. So we take 5 students here. So according to this table, in the first group we can take 3, second group 5, third group 5. So totally you can take how many students? According to this group, you can take 13 students. That is the maximum number of students you can put inside the van. Is that clear, everyone?
So can you explain that again?
Okay. Right.
Excuse me, sir.
Yeah, Shiva.
Sir, how did you get on? Why did you get only those 3 groups?
Yeah, okay. Yeah, okay, fine. Now the question is, find the maximum number of students that it may be possible to take in the above van. Right. That's why I asked you the first question. To put more students into the van, would you take the larger weight students or the smaller weight students? That's the first question I asked. What would you take?
Smaller weight students.
Smaller weight. If you take larger fat students, you can put only less number of students, definitely. Okay. So then you start from the least number of weights and you work your way downwards until you get 600 kilograms. Did you understand that first of all?
Okay, sir.
Right. You understood that. Now, in each group, we need to take the maximum number of students. Right. So would you go for 40 kilograms? Maximum means the weight should be the least. Would you go for 40 or 44?
40.
40 kilograms. So we think that these 3 students are 40 kilograms. So first group, all the 3 we can take, that will be 120. Next group, 5 students, we take it as 44, that will be 220, so 340. Now out of 600, 340 is already gone. How many is remaining? 260 is remaining. So if you put all of these 9 students, we saw that it is more than 600. So we have to think how much out of these 9, how much can be fit inside the van. So then altogether multiplication will give you 260. If you take 5 students, you get 240. If you get 6 students, it will be 288. It is more than 600. So then the maximum we can take is 5 students. So in total, 555, that will be 13 students. Is that clear?
Yes, sir.
Others, okay?
Yes, sir.
Yes, okay.
Yes, sir.
Right now, come back to, we skipped 2 questions, 2020 and 24, right? Yeah, I'll discuss one because already there's only 10 minutes more. The next one, try it at home, okay? Both are similar questions. That's why I kept it last, both of them, right?
Can
Now
you
come
say
2020.
24.
Yeah, 20 and 24. We skip 20 also. I'll do 20. You guys try 24 at home, okay?
The 24 is kind of hard, sir.
Okay, right. Fine. Do 24. No problem. Right, take 24 then. Right. The frequency table given below, in the information related to the number of hires, a certain tree will engage in each week. Given, depending on the question, can there be half hires? Can there be decimal number of hires? Yes. Can there be decimal number of hires?
No.
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 Right, okay, someone can get down halfway through, but it's still one hire. Like we don't take, okay, it's a half hire. No. Anyone who get in and get down, that will be complete one hire. So then you can't have decimals in your hire. Now tell me, in this question, the data collected, is it continuous data or a discrete data?
Continuous.
No decimals. If there is no decimals,
Okay,
discrete?
decimals.
discrete data. Okay, because there are no decimals, I told you there are two types of data, continuous data and discrete data. If there are only whole numbers, then it is discrete. If there are decimals also, then you call those what? Continuous data.
Continuous.
Now we saw that if it was continuous data, okay, if it was continuous data, in one class interval, the ending and the next class interval, the starting is the same. Right? Why? Because we have to include the decimal values. But if it was a discrete data, you don't have decimals. Okay? So in that case, the ending and the starting should not be the same. Right? It can start, we can end with one number and we can start with the next number. Right? Now there's only a very tiny difference between the how to calculate the mean value of the continuous data and discrete data. That difference I'm going to show you. Then you can do the next question on your own as well. Okay. Right. Now the difference is finding the size of the class interval. Now, for example, I'll compare with the continuous. See here, 20 to 30, 30 to 40. Now 40 to 50. Now we said that in the standard way, how do you read this? We say any data that is 20, more than 20 or less than 30. So what are we going to include? We are going to include 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Are we including 30? No, 30 will go to the next class interval. So then what is the size? The size is 10, not 11. So easily 30 minus 20 will give you 10. That's no problem. But it's not the same thing when you take a discrete type of data. See here, discrete type of data, 9 minus 4, if you subtract, sorry, 9 minus 5, if you subtract, you get 4. But actually 4 is not the size of the class interval. I'll tell you why. We'll count here, starting from 5, 6. Now here, if you read this, all the values will be included. What do I mean by all the values? From 5 to 9, all the values are included. That is, any value equal to 5 or more than 5, any value equal to 9 or less than 9. So all from 5 to 9 are included. So 5, 6, 7, 8, 9 are here. The size of the class interval is 5. You can't subtract directly and get the answer. There you could subtract, because 30 was not included. So 30 minus 20, 10 is easily the size of the class interval. But here, that's not the case. Why? Because both 5 and 9 are included. Here, both 20 and 30 are not included. 30 will go to the next class interval. So here when you are calculating the size, remember in a discrete data, always count. If you are confused, count in a discrete type of data. Continuous, directly subtract, get your size of the class interval. But discrete type of data, count 5, 6, 7, 8, 9. The size of the class interval is 5. That is the only difference you're going to, you will see in a continuous data and a discrete data. Okay. Now, see here, we write the frequency. So frequency 1, 3, 5.
Excuse me, if you don't mind, can you explain it again?
Yeah, I'll explain again. 6, 5,
So it's 4, not 5.
4. Sorry?
4, right?
Right, I'll explain again. See here, the difference between you guys should understand first of all. Hopefully, you have understood what is discrete and continuous, right? After you understood that, the only difference is when you find the size of the class interval. Now, in a continuous data, how do you read this frequency or the class interval? Any data that is 20, more than 20, and less than 30. We don't include 30 here. Okay? If 30 comes, we put it to the next class interval. Did you understand that?
Yes, sir.
Yes, everyone okay? The one who had a doubt, I didn't see your name.
Yes, sir.
Yes,
got it.
okay. Right. So, but in a discrete data, how to read this class interval? Data from 5 to 9. So 5, 6, 7, 8, 9 is also included. Now here when you are finding the size of the class interval, you can directly subtract 30 minus 20, that is 10. Why? 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We don't include 30, so that is 10. 30 minus 20 is also 10. So always if it's continuous, you can directly subtract and get the size of the class interval. But if it is discrete type of data, when you are finding the size, be careful. 9 minus 5 is 4, but the size of the class interval is 5. Why? Because we include 9 as well. So 5, 6, 7, 8, 9. So size of the class interval is 5, not 4. Is that clear? Okay?
Yes, I got it. Thank you.
Yeah. Okay. Now first question, find the mean number of times the three-wheeler was hired a week. Okay. So then here, so number of hires engaged in each week. So they tell me the mean value. What will it give you? And then the question that they have given, the mean value will give you number of hires per week. For 1 week, how many hires? That we are going to find the average value of that. Okay. Now here mean value as before. 5 plus 9, that is 14. 14 divided by 2 is 7. As usual before, to get the next mid value, we keep on adding the size of the class interval. So 7 plus 5, that is 12. 12 plus 5, 17. 17 plus 5, 22. 22 plus 5, 27. 27 plus 5, 32. 32 plus 5, that is 37. Okay. So then 30, so we got the mid value now. Now what if find the assumed mean? Sometimes in a question they'll tell you what to take as your assumed mean, but here they have not told you. So always go for the what? Always go
Model
for
class.
the mean value
Model.
of the model class, right? But here I'll not go for the mean value. I'll go for another assumed mean and show you, you'll get the same answer. Those who have done, you can compare your answer and see. Okay. Now what do I go? I will go. Sorry. I will take the mid value of this, right, as the assumed mean, right? You might have taken this as the assumed mean, no problem. Still, you get the same answer. Now, here the deviation is 0. Whatever more, positive deviation, whatever less, negative deviation. This is 5 more plus 5, 10 more plus 10, 15 more plus 15. Likewise, minus 5, minus 10, minus 15. This is for deviation for one data. You have to find the total deviation. Minus into 1 is minus 15, 3 into minus 10, minus 30, then 4 into minus 5, minus 20. Here it is 0. Right? 5 into 5, 25, then 7 into 10, 70, 4 into 15, that is 60. Then here you get 70, 130, 155, positive 155. Here 20, 30 is 50, then minus 65. Do the subtraction, you will get 90. Okay? Is that clear?
Yes, sir.
Yes.
Right. Now here, how many weeks did they give you? You have to add it, the number of weeks. 1, 3, 4, 8, 14, 14, 19, 26, 30. 30 weeks. Right? Now we can find the mean value. Assume mean, we take it as 22, right? 22 plus sigma FD is 90. 90 divided by 30. So then that is 3. 22 plus 3, that is 25. So then 25 hires, remember the units, okay, per week. Right? 25 hires per week. That's your unit. Okay. Roman number 2. How many hires can the three-wheeler driver expect in a total of 52 weeks? In 1 week, per week, 25 hires. So 52 weeks, how do you find? 25 multiplied by 52. Simple as that, right? So 25 into 52, do the multiplication. 5 into 2 is 10, 2 into 2 is 4, plus 1, 5. Leave a space. 5 into 5 is 25. 2 into 5 is 10, 10 plus 2, that is 12. So 0, 10 here, 3, 1. So then you get 1,300 hires. Okay, so in 52 weeks, you will get 1,300 hires. Problem number 3. Let us take that the average distance of a hire, one hire average distance is 5 kilometers. If the three-wheeler driver charged a fee of rupees 100 per kilometer, what can he expect as his income for 4 weeks? For 1 week, how many hires? 25 hires. So first of all, for 4 weeks, you have to find the number of hires. That is 25 into 4. So that is 100 hires. In 4 weeks, he will have 100 hires. One hire, 5 kilometer. So then the total number of kilometer, right? 100 into 5, that is 500 kilometers. For 1 kilometer, 100 rupees. So then total value 500 into 100, that is rupees 50,000 rupees. Is that clear? Problem number 3,
Yes, sir.
right? Last one.
Yeah, sir.
What is the minimum number of times? Yeah, any doubt?
When I take the assumed value, I should take the highest value, right? In the mid value.
Highest of the mid value.
Yeah, the assumed mean.
Highest of the mid value, you're saying 37.
No. When I select the assumed value, should I take the highest one in the mid value column?
This is the mid value column. You're asking me, this is my assumed mean. When you're taking the assumed mean, you're asking me whether we should take the highest value. Is that your question?
Yes.
No. We don't go for the highest value. I never said that. I told you most of the time, how do you take the assumed mean? You look at the model class. What is the model class? The class interval with the highest frequency. I think that's what you're meaning, right?
Yes, sir.
Okay. The class interval with the highest frequency, that is 30 to 34 here, right? But I can take 32 as my assume mean, right? Because that is the model class, the mid value of the model class. But here as a change, I always go for that, right? As a change, for you to show that if you take any mid value as your assume mean, you will still get the same answer. As a change, I took this. You can take anyone as your assume mean. Is that clear?
Yes, sir. Thank you.
Did everyone understand that?
Yes,
Yes,
sir.
sir.
Right. Good.
Yeah, sir.
Last one. What is the minimum number of times? Minimum. Underline the word minimum. Minimum number of times the three-wheeler may have been hired in total in the weeks in which the number of times it was hired was less than 20. Okay. So then what is the minimum number of times the three-wheeler is hired? May have been hired in a total, may have been hired in total in the weeks in which the number of times it was hired was less than 20. See here. So then the weeks that was hired, which was less than 20. Can you tell me how many weeks the three-wheeler was hired less than 20? Here 19, right? This is the point where the three-wheeler was hired that was less than 20. So how many weeks? 1, 3, 4, 8 weeks. For 8 weeks, the three-wheeler was hired for less than 20 times. Now they're asking you what will be the minimum value. If they ask you the minimum value, we have to take the minimum number of times it was hired. So then, if you take the first class interval, the number of times it was hired was once. Minimum time, number of weeks it was hired was once. Minimum hires, it was 5. So for the first group, what was the number of hires? That is 1 into 5, that is 5 hires. Second group, 3 weeks, it was hired a minimum of 10 times. So 3 weeks into 10, so that is 30 hires. Third group, minimum of times it was hired 15 times. How many weeks? 4 weeks. 15 into 4, that is 60. So in total, 95 hires, it was for the minimum number of times. Is that clear, everyone?
Yes, sir.
All right.
Yes, sir.
Yes.
Out.
Yes,
Okay,
sir.
do that 2020 on your own, right? Next week, we are starting, coming Saturday, right? We are starting data representation, that is your pie charts, histograms, frequency polygons,
Excuse
and
me, sir.
cumulative frequencies. If you guys have any idea, can drop me a message to join the class. Okay, coming Saturday,
Mhm.
that will be a paid session, yes?
Sir, are you done
Wait,
with
all
graphs?
Graph questions.
We were done, right? Didn't I do everything?
So is there any way to get the recording?
Recording. Okay, you drop me a message. I'll give you any possible ways, okay?
Okay, sir, thank you.
Excuse me, sir.
Yeah.
Sir, if they ask for the maximum value, then you would take 9 or like from the
Exactly.
given table.
Yes.
Thank you, sir.
Okay, you're welcome. Right, everyone, good night then. If you want to join the classes, drop me a message, right? Take care. Assalamu
Okay,
alaikum.
sir. Thank
Bye.
you, sir. Good night.
Assalamualaikum, sir.
Good night.
Thank you, sir.
Welcome. Bye bye.
Good night, sir.
Good night. Good night.
Sir, is